The year is 2120 and you're on vacation in outer space. Your family's on a space cruise complete with swimming pools, dance contests, and concerts. But how do your feet stay firmly attached to the floor? Well, let's review some basics. We know from Newton's laws of motion that objects travel in straight lines unless acted upon by outside forces. An example of this is a soccer ball that is kicked in a straight line and only changes direction when the ball is interrupted by a member of the opposing team who redirects the soccer ball by kicking it. The opposing team's soccer player has applied an outside force on the ball which changed the ball's direction and speed. But then what's going on here? The ball isn't exactly traveling in a straight line. This must mean that there's an outside force acting on the ball. Let's simplify this scenario by imagining that it happens in space, where there are no y-direction forces such as gravity. And let's say that the ball was set in motion and remains at a constant speed by the application of an outside force applied parallel to the ball's path. Let's look at a diagram that represents this scenario. The ball moving at a given speed actually would move in a straight line, but can't because the force applied to the ball by the string does not allow it to. The end of the string in my hand exerts centripetal force on the ball, which means that it applies a force in the direction of the center point of the circle. The result is that the ball is constantly being pulled towards the center of the circle, and this means that the ball can't fly any farther from the center point of the circle than it already is. If the outside force acting on the ball, the centripetal force, was suddenly taken away, the ball would fly away from the circle on a tangent line to the circumference because the only force then acting on the ball would be the force applied to get and keep the ball moving at a constant speed. But since there's a centripetal force acting on the ball in the direction of the center point of the circle, then why doesn't the ball get closer to the center point? Well, it would if the force applied parallel to the ball's path was suddenly eliminated. It's the combination of the force parallel to the ball's path and the force directed toward the circle's center, or the centripetal force, which caused the ball to stay a constant distance from the center point of the circle. This moving arrow shows the sum of the two force arrows and indicates the direction the ball will move in. The concept of centripetal force has been applied to carnival rides like the Gravitron, sports like high jump, and scientific devices such as the centrifuge. But how does this impact space travel? Well, if we could send a huge round spaceship into outer space, we can make it spin fast enough to mimic gravity. The walls farthest from the center of the spaceship would become the floor as objects and people find themselves being pulled towards the walls by the forces applied parallel to their movement in space. In the spaceship's structure would take the place of the string in the ball and string model as they prevent objects from leaving the circumference of the spaceship. This solution is technically possible. The only problem with this vision is that a spaceship of this size would be extremely expensive to send into space. But maybe one day, when only the farthest reaches of the universe remain undiscovered, scientists will use centripetal force to explore the stars.